Thank you, everyone. We'll make a start, if that's okay. Thank you. Welcome. Our next talk is Delay, Detect, Defend, Preparing for a World in which Thousands Can Unleash New Pandemics. Our speaker, MIT Professor Kevin Esvelt, leads the Sculpting Evolution group in advancing biotechnology safety. The creator of synthetic ecosystems to rapidly evolve molecular tools, he is best known for inventing CRISPR-based gene drive systems, capable of single-handedly spreading genetic alterations from laboratory organisms through wild species and ecosystems. His laboratory seeks to safeguard biotechnology against mistrust and misuse by developing pioneering technologies with community guidance, inventing early warning systems to reliably detect all biological threats, and applying cryptographic methods to enable secure and universal DNA synthesis screening. Please give a warm welcome to Kevin Esvelt.
Thank you, Ollie, and to all of the organizers who put this together, and all of you for coming to deal with biorisk, which is unfortunately one of those nearer-term catastrophic risks. And as we've all lived through the last couple of years, there's no real need to explain why it would be decidedly unfortunate if many people could unleash the next COVID. The reality is, we are probably going to live in that world within the next decade or so. And right now, of course, being in downtown Boston, we are probably one of the cities targeted by nuclear weapons. And many of you are probably aware of the odds of that happening. But there's just 9 nuclear-capable actors in the world. And with bio, it could be much worse. So what can we do? The point of this talk is to explain, not just articulate the problem, but also what can we feasibly do about it, because most of that does not actually take place in bio itself. We are going to need folks from other disciplines. So first, COVID has proven that pandemics are at least as dangerous as nuclear weapons. They spread, of course, through air traffic. We saw this with COVID as well. And we were unable to block them. Sufficiently contagious virus, there's just not much we can do today. But while it doesn't look like there's a great case for blocking nuclear weapons, there is a pretty good case that we can make a world that is virtually immune to pandemics, or at least much of it. That's the goal. How do we get there? Well, first we have to address the problem, because the sooner it happens, then the less time we have to prepare. So delaying. The problem is there are entirely too many people like me, and specifically like me and any of the rest of you in the audience who have been trained in molecular biology. There are now protocols online for assembling, say, a coronavirus or an influenza virus just from using standard laboratory materials. And there's a lot of us who can do this. If you just count folks with doctorates, you can calculate that there's probably 30,000 or so people who can make influenza viruses from scratch. And this is because scientists, of course, want to study these viruses, come up with better cures, and so forth, and that is why it is now a relatively straightforward matter to generate and test new virus configurations using what now amounts to the world's best Lego set. This probably does not sound like the greatest of ideas to anyone in this room, but if your goal is to cure disease, you need the tools to study the enemy. And that's not going to stop. It's already there. There's nothing we can do about it. Number 2 is just DNA, and especially gene synthesis for long genes, is now extremely cheap. The first virus assembled from synthetic DNA was put together in 2002. In the last 20 years, the cost has dropped by 1,000-fold and is likely to continue to drop. So it costs less than $1,000 to make 1918 influenza virus today. Number 3 is the one that we don't have yet. We don't know today which viruses would cause another pandemic. As long as that's true, there's no proliferation. But as soon as someone says, this one could do it, and there's a complete genome sequence available, combined with virus assembly protocols for that family, that's when the window of risk begins. So that's what we need to delay. How can we do that? Well, what are the ways that you can identify a virus as capable of causing the next pandemic? The viruses that can cause pandemics are the ones that currently circulate in the human population. We know that they can because they already do spread amongst all humans, even though many of us have been exposed before and have pre-existing immunity. So the metric for a pandemic-capable virus is, do its traits as measured in the laboratory to the best of our capability stack up to endemic human viruses of the same family that are already circulating in people? Because if a new animal virus, to which none of us has pre-existing immunity, has those traits, then there's a pretty good chance that it could cause another pandemic. So we just need to not perform those experiments. Similarly, we need to never test an engineered human virus for its ability to evade all of the different forms of pre-existing immunity that our bodies develop. If we can avoid that, or at least delay it for as long as possible, because preventing it entirely is probably not in the cards, then we can buy ourselves additional years to prepare our defenses. There's lots of tremendously well-meaning scientists who want to prevent the next natural pandemic who are running these kinds of experiments. They earnestly believe that the best way to prevent the next natural pandemic is to identify every virus out there in nature that could cause it, and to share that knowledge with the world so that we can develop better molecular countermeasures, yes, but also ideally intervene in the wild to prevent spillover. There's lots of reasons why this is, probably not worth the proliferation cost of what they're doing, but they're not thinking about fighting humans. They're not used to human adversaries. Most of us in science, at least in the life sciences, think about nature as the adversary. It's nature that throws new pandemic viruses at us. And so the folks who are the source of the greatest risk is not foreign bioweapons programs who would never share their results and recipes with the world. It's actually well-meaning scientists who are trying to save lives, which I think should be a recipe in humility for all of us, just how readily we can go wrong. But we have to try to persuade them otherwise, and try to persuade the world otherwise, because in the wake of COVID, people feel very acutely that pandemics can really wreck our lives. And if we point out that maybe perhaps we don't really like the fact that Putin has all of these nukes, perhaps we don't want to give many, many more people the ability to ignite pandemics, that's a fairly persuasive argument, and it's one that we need to make because it can buy us time. This is the problem. Pandemic proliferation would be much, much, much worse than nuclear proliferation. And of course, COVID spread from a single site, as did each subsequent variant. Any deliberate actor who is malicious would not be so kind. So, what do? Delay, reliable detection, and reliable defense. Those are the goals. Delaying means denial, first of all, denying people information and access to the physical materials they need in order to make pandemic class agents. Reliable early warning means we need to monitor to ensure that we can detect any given biological threat that exhibits the characteristics of something that can cause tremendous harm. And for protection, we need to figure out ways of actually preventing the spread of human-targeted biological agents. Many of you may be involved in shaping national policy. It so happens that the US is probably the worst offender when it comes to identifying these kinds of viruses. There are other nations that do it as well. But in the US, a major problem is that we do see this as a problem for CDC and NIH. Pandemics are not seen as a defense issue. Even biosecurity, people tend to think of it as, well, that's a global health issue. This is not a global health issue. This is a defense issue. And if the Defense Department took it seriously, they actually have the budget to deal with it. So we might actually get some help there. We have to persuade folks in defense that this is their problem. There's some national policy levers that we can pull. The select agent list governs all research in the United States, and it is the focal point for many international agreements. If we agree to add viruses to the select agent list as soon as anyone performs any one of those experiments indicating pandemic potential, then if I'm a virology lab, I'm studying this virus, And I know if I perform a certain experiment and it comes up with a positive result, it gets classified as a select agent. The cost of my research just goes up by 4 to 5-fold. That's a huge cost increase. I don't want to perform that experiment as soon as that happens. So as soon as we make it clear that any potential pandemic virus needs to go on the select agent list immediately, we immediately deter all of those labs from performing those experiments. They just won't want to know. We need to ensure that health agency research is actually overseen by security experts. Right now, NIH, for example, sets their own regulations, their own oversight. They work to regulate the research they fund with the institutions and researchers that they support. There is no external oversight except for a body that NIH appoints and has in the past completely fired and replaced when they didn't like what they said. That doesn't sound like very effective oversight, and this is something that we can point out. The last one is that as a society, COVID really should have taught us that these things are at least as dangerous as individual nuclear weapons. But we don't treat them that way. Depending on how you count, the US spends somewhere between $2 and $70 billion a year on nuclear nonproliferation. Yet, on the other hand, agencies like USAID, promoting international development, are funding research into pandemic proliferation. They don't mean to, but they haven't thought of it that way. It's just wildly inconsistent. If we devoted even a fraction of the resources we devote to nuclear nonproliferation into the pandemics and biothreats, we'd be in a much better position. Internationally, we have, thanks to Matt Messelson, who is a hero if there ever was one, we have the Biological Weapons Convention. Establishes extremely strong norms that nations just should never make biological weapons, should never assist others in doing it, should never tolerate anyone doing it in their territory. It's toothless. There's no enforcement mechanism. There's hardly anyone actually working to identify violations. And in fact, it requires a signatory, a nation state, to bring allegations of violations to the Security Council, which requires convincing a nation to actually do that. This is a particular problem because when it comes to identifying pandemic viruses, the US and China are the two nations leading the charge. So unless we can get our house in order, it's a little bit unlikely that anyone will be able to do it. But for any of you who are from the UK or have influence in the UK does not sponsor this kind of research, has not sponsored this kind of research, and is in a great position to take up this call and say, you know what? This is not in any of our strategic interests. No established nation state has an interest in letting tens of thousands of people ignite pandemics whenever they want. We could make progress there. The challenge is Article 10 of the convention says, in effect, as long as you're doing it for peaceful purposes, it's okay. But if that means it's okay to give blueprints for plagues to tens of thousands of people because you had good intentions, then why do we have a biological weapons convention? There's just no point. So we should also consider just going back to the drawing board and seeing if we can lever up support for a specific pandemic test ban treaty. Again, go back to the nuclear analogy. If we invested a slightest fraction of the resources into bio that we put into nuclear when it comes to non-proliferation, we'd be in a much better position. We haven't, there is a nuclear non-proliferation treaty, there's a nuclear test ban treaty, although that one hasn't come into full force yet. Why don't we have a pandemic test ban treaty? If we were consistent, we would. But none of that is going to be enough. We also need to restrict access to individuals who are ultimately the source of the risk. We need to assume that we're going to lose control on the information side. Right now, the best estimate for how many people are going to have access to these things is going to be somewhere in the tens of thousands of individual actors who just happen to have the laboratory skills to follow one of these 120-step Nature Protocols papers. There's also a bunch of well-resourced actors who are mostly nation states or well-funded teams who could also do it. But most of those lone wolves who can do it on their own rely on synthetic DNA. That is, they can't make the DNA encoding the virus on their own. They have to order it from a commercial supplier. If we could actually screen virtually all DNA synthesis in the world such that whenever someone tries to warn the world about a new threat, which is how most scientists think about this, then we can add it to the screening database, and then people won't be able to order the DNA for it. And that would reduce access by probably 100-fold. But it would be even better if we can get that in place. What if we could disseminate the idea that maybe we shouldn't share blueprints for plagues? That sharing that with the world is not actually the best thing, that information hazards are a problem, and the responsible thing to do is instead report one's concern so that the relevant agent, along with a suitable number of decoys, can be added to the hazards database. And then scientists would not be publicizing the risk while there's still no patch. No one would do this in cybersecurity, but people somehow think in bio that that is the appropriate thing to highlight the risk. That is something that we can change if there is something positive and obvious that they could do to help. And so DNA synthesis screening is one such thing. So we've been working on this with an international team of mostly cryptographers for some number of years now. And we have a system that we believe will work that can protect the identities of the synthesis orders themselves while still screening them against hazards without, again, disclosing the orders themselves, which of course are the roadmap to whatever a pharma or biotech is doing research-wise, or what we think the hazards are, if need be. So the challenge is, can we get something like this, or ideally something even better, in place within the next couple of years, before someone reveals the recipe to a plague? We've been doing some work on this just to show how it works, and there's a number of folks, I think, in the audience today who have contributed to this. Dana, and I know Brian is here today, tested this in the lab just to see how sensitive it is, and they found that the way it works is it looks for particular windows in a genome and computes functional variants of that sequence and checks to see whether the order matches any of the functional variants as well as the original. And we found that if we defended just 9 pieces of a virus with a small number of variants each, we blocked almost all attempts to make that virus by the other half of the lab. And the actual system defends each hazard at 170 windows, not 9. So we're pretty confident that this is sensitive enough to do the job. And we're currently working with industry partners to convince them that this is also good enough, given that they might face legal liability someday. But at the end of the day, that's going to fail too, right? Even if we get DNA synthesis screening in place, there's still going to be at least 1,000 people, or at least groups, who could still make pandemics and release them. And if we go back to Aum Shinrikyo, the apocalyptic cult in Japan, their biological weapons program was led by a graduate-trained virologist who specialized in what passed for genetic engineering in the 1990s. He was executed for assisting the cult in releasing chemical weapons on innocent people in the subways. They tried to get their hands on Ebola. Today, anyone with that kind of background could definitely make a pandemic virus from scratch. And the cult had the resources to make the DNA, even if they didn't have to do it conventionally. So we're going to have to deal with this problem. The number one most important thing when you face with a new threat is we know that it's going to be spreading exponentially, so we need to detect it as soon as possible. And it has to be reliably detected. We can't afford to let something slip through. So how can you do that? Well, what defines a biological threat? It's biological, which means it's made of nucleic acids. And it's a threat, which means it must be affecting the whole world. That means it has to grow exponentially. Any biological threat that doesn't grow exponentially isn't really much of a threat. So one option is to sequence everything out there and look for patterns of k-mers, short fragments of nucleic acids, that are growing exponentially together. Because any catastrophic biothreat must display that particular signature, or it's just not a threat at all. So a number of folks on the team are laying the groundwork for this, but it's obviously going to be a much larger project, and there's a lot of work to do concerning where should we build it, where should the nodes be, what do you sample? I mean, obviously it's going to involve untargeted metagenomic sequencing on samples from ideally the air traffic hubs, because presumably those are the places where it's going to be spreading most rapidly. Maybe the planes themselves, plain wastewater, air filters and the like, maybe even sampling flight crews directly if we can persuade them to give samples. That raises privacy issues in the ways the others don't. But once identified by this untargeted approach, just looking for the signature of spread or something similar to that, once you know what it is, there's lots of folk who are doing, say, COVID monitoring in wastewater in cities throughout the world. Even the CDC is doing that. Once you know what it is, you can say, look for this thing. And then all of those monitoring stations who are not thinking about the defense side will be able to pick it up. And so as soon as we know the thing is there, no matter what other traits it might have, we can learn exactly where it is. But that doesn't mean we can do anything about it. If COVID has taught us anything, it's that, great, early warning would have been fine. That would have been fantastic. Maybe we could have slowed it down by, say, shutting down international air traffic. That would have bought us time. But it's hard to imagine that we could have actually contained and stamped it out, which is what we're going to need to do. And if we can't do that on a global level, which we might not be able to do, then that means that any nations that do manage to suppress it, because again, if there's an adversary releasing it, they're probably going to release it in multiple airports at once. So we're probably not going to be able to just stamp it out. But some nations may be able to get it under control, suppress it, and then they're going to have to keep it out. Which means that any nation that succeeds like that is in a predicament kind of like China is in today with the Omicron variants. And they're losing. So what can we do in terms of technology that will give nations that are less well suited to welding people in their apartments the tools to suppress pandemics? Well, those tools are not going to be biomedical. This is really hard for folks who are biotechnologists like me to accept, but our skills, barring the detection side, are really just not going to be super reliable when it comes to defense. And there's a number of reasons for that, but the easiest one to explain is just logistics. Omicron spread from a single point source in Africa. Within 100 days of it being identified and sequenced, it had infected more than a fifth of the US and at least 2/5 of Europe. Note that 100 days is the stretch goal of the White House pandemic preparedness plan and every other plan of every other nation I've ever seen for a vaccine becoming readily available. That's a virus, again, spreading at one point source that was not initially that near an air traffic hub. Anything released across multiple such hubs by a deliberate adversary is going to spread much, much, much faster. So medical countermeasures across the board are just too slow. That does not mean they can't save a lot of lives, but they're not going to be reliable either. Note that we still don't have an HIV vaccine. We can't even reliably beat nature when it comes to fending off nasty biological agents. If we can't reliably beat nature, why would we imagine that we could defeat an enemy who knows what we have in our pocket? If the adversary knows what therapies you have stockpiled, they can design around them. So we better, if we want to rely on therapies, we better keep some of them secret. That's not something that NIH policy even allows today. Your grant requires you to disclose all of your data. You cannot keep some of it back on grounds of, we need to show that we have a viable therapy and we have several alternatives that we're not telling you about. That's just explicitly not allowed. They don't think that way. So when it comes to reliability, the answer is just not in biotech. Biotech cannot reliably defend us from biotech, but other things can. Most obviously, if you are a human and you are worried about a biological threat, the best thing to do is to ensure that it does not come in contact with you. And this is an eminently achievable goal. You can go the minimalist route, $40 on Amazon today. You can have a powered air purifying respirator of the most basic form that just connects to a mask. You can strap it on your arm and go running with it and the like. I don't actually think that that would save you from COVID, let alone something like measles, but it's a step in the right direction that would mitigate everyone's risk if people were willing to wear them. In the middle is a more standard mask for a powered air purifying respirator. You can see the hose going down the back. It's not exactly what I would be happy to see everyone wearing all the time, shall we say. There are some style benefits that I think are perhaps lacking there. And at the end of the day, people have to be willing to wear this stuff, right? If there's going to be a new warning, people don't want to go back into the COVID days. That's why it's delightful to all be here together as people in a room without worrying about it. This time period is probably not going to last. But if we have to wear anything like this, then let's make it as comfortable and stylish, lightweight, durable, easy to use, the works as possible. This is doable. We've thrown hardly any money in this. Air purifying respirators were designed to give you clear air in case you're working with industrial hazards. They were not designed, for the most part, to keep you from getting infected with viruses. We can do better. On the far right is an image from a startup that is looking at using far UVC light, which is still microbicidal, but it doesn't look like it harms our skin, and probably not even our eyes, meaning all of the lights in this room could plausibly be augmented by far UVC, and it would just sterilize all of the air around us all the time. What they also want to do is build broadcasters that you can wear and would sterilize the air around you as it comes towards you. If that could work well enough, we might not even need masks. That would be great. These are the kinds of things that we all need to investigate, but the bottom line is all air touching mucous membranes must be sterile. And if we can do that, however we do it, this could be like radioactive isotopes that emit alpha particles, which similarly are microbicidal but don't penetrate enough of our skin to be harmful. There's lots of plausible ways we can do it. We need folks outside of bio to figure it out. Healthcare workers might have a little bit worse. What if there's an Ebola type thing as well? Not just respiratory. What if it's like fluid mediated or contact mediated? If it's surface contamination, you can't just take your mask off the way most of us have gotten used to with COVID. You'll contaminate yourself and then you'll end up touching your eyes or your nose and then you'll be infected. This problem has actually been solved. If you're willing to wear a suit like that, it's designed to make it easy to doff without getting contaminated. I'm sure we can do better than that, but that kind of suit is basically proof against virtually anything that bio can throw at you, at least while you wear it. And it's designed so that you can doff it without contaminating yourself. So we already have the basic tech. It's just, I don't think people are going to want to actually wear it. And that's the thing. The people we need to wear it are actually not most of us in this room. It's essential workers. It's the folk who ensure that we all have enough food, water, power, law enforcement, and possibly healthcare. You can, in an emergency, do without the healthcare, but the other four are absolutely essential. If those people have good enough protective equipment through any combination of mechanisms, then civilization is okay. At least until we run out of materials that are provided by supposed non-essential workers, in which case we need to have protection for them too. So we can't assume that the global supply chain will remain intact or be swiftly repaired if this sort of thing happens. That's another policy area that we need to work on. How do we ensure that we have resilient stockpiles of whatever is required in the event of the next pandemic? But beyond that, if we can just identify all the essential workers, make PPE that is good enough and that they're willing to wear, and arrange for it to be delivered to them when the warning is raised, we're actually in really good shape. There's lots of other things you can do. As I mentioned, the far UVC on the right. Any of you interested in semiconductor physics and the like, some far UVC LEDs would be great, or really any other way of generating that class of radiation. HEPA ventilation, air curtains, all these things could improve our safety within buildings and the like. Even things we already have UVC LEDs. You know, what if every of these walls had UVC LEDs pointing upwards so that most of the air in this room is just sterilized all the time? You can certainly add them to ventilation ducts. That's stuff that we have now. We just need to actually implement it. Anything like this just reduces the overall risk, as does the last thing, which is diagnostics. So here is where folks in bio really can help. Once the threat is ID'd, if it's in a bunch of people, we'll know which cities it's in, sure, but you still don't know necessarily who has it. Once you can figure that out with diagnostics, then we can help prevent other people from getting it. But it might be too fast for contact tracing. But there is a way around this. If you can give people early warning, we know that one of the most powerful determinants of how many people got infected in COVID in a given wave is how cautious people were being. And the problem is, sort of collective societal response was based on risk perception, which only increased when either case counts went up or especially when hospitalizations and deaths went up, which was, of course, a few weeks too delayed. What if we could give everyone an individualized early warning telling them how many of your connections, your first-degree connections that you normally come in contact with, or your secondary connections, their contacts, or the ones beyond that, or the ones out, what fraction of those have been infected already? If you could give everyone that information, then they would start taking precautions before they get infected. But this is probably the hardest part. We can invent the necessary tech. We may not be able to get government to help us, but we can probably persuade enough people, build enough companies that we can get everything out there. But what we can't do is make people use it. We can't persuade them that it will be necessary. If there's an 80% lethality pandemic, our job is probably done for us. But at that point, a lot of people will have died needlessly. So we have to find some way of persuading people to actually use it, and ideally do so in advance of the actual threat coming their way. So these are the things we need to do. Delay, detect, defend. Very little of this has to do with bio, which means we need the help of folks outside of bio. And those of you who are in bio, we need your help on policy, and we need your help on these other areas of determining where the threat is. That is not to say that if you're really enthused about vaccines, you shouldn't do that. There is a time and a place for vaccines. The fact that they're just not reliable doesn't necessarily mean you shouldn't do it, but we need folks on the other areas. Thanks, first of all, to the Secure DNA team, which is science diplomacy at its best, academics from all over the world working on this, mostly cryptographers, as well as folks in industry and development team putting it together. And thanks to my lab for putting up with me in harping about how biotech isn't always the best thing for the world, even though we run a biotech lab ourselves. They're really amazing. Final thanks to all of you for your attention. Happy to take questions.
Wonderful. Thanks so much, Kevin. We'll be taking questions from the Swap Card app. A few are there already, and I'll be fielding them to Kevin. Our first one to open up with is, what are air curtains?
So air curtains is an idea where, suppose you want to have dinner with friends in a restaurant, but you would like to see them. You don't want to have to wear one of those suits with a face covering or anything like that. Can you sculpt the airflow in there so that you have essentially separate bubbles of air that you're breathing, so that the curtains of air actually ensure that nothing that you exhale gets to them, and vice versa? The air is invisible. Can we create barriers made of air to reduce infection?
Thank you. Someone asks, how should we, the audience, and I know you think about this yourself, balance the benefit of raising awareness of the problem with the risk of spreading attention to people we don't want to know about?
Yeah, so information hazards is really the key stickler in bio. And the real challenge with it is that you don't want to even articulate a particular concept that people aren't broadly aware of. Because most scientists really just don't think about this. There's no security mindset at all, and we're better off that way. I really don't want us going around telling scientists that bio could be horrifically misused in this way, because then they might decide to think about how it could be done. And that could lead to earlier disclosure, and we might end up accelerating the day when nasty things become available. So you'll note I haven't talked about engineered really anything other than the engineering tools necessary to stitch the thing together. We don't need to make the case by referencing any fancy human-engineered pandemic class agent. You can just say, you know what? If people post this list of pandemic-capable viruses rank ordered by threat level, then people could release 10 different pandemics simultaneously across many different airports. That could plausibly threaten civilization right there. There's no need to invoke making things worse with biotech. And that means we don't have to. There's just no need to investigate how things could be made worse in order to persuade people of the magnitude of the threat. That is one thing that COVID, I think, has given us.
Thank you. Someone asks about antibiotic resistance. Is that something you think about as well, and how do you think about that risk?
Yeah, so antibiotic resistance is one of those problems where you can do a lot of near-term good by working on it, potentially, but it's really a civilizational problem of effort. There's probably about 300 people in the world total who work on overcoming the problem of emerging antibiotic resistance. If we actually threw money at the problem in terms of the development cycle, we could almost certainly solve it. I mean, we still haven't sequenced most of the organisms in the soil. There's almost certainly a lot of antibiotics out there in nature that we haven't tapped yet, never mind chemical space. If we invest in it, I think we can solve it. And most of the pandemic class agents that are of concern are not microbes, or at least they're not bacteria. I'm considerably more frightened, for the most part, of viruses.
It was uncharacteristically optimistic. That's great. Someone asks about how to test the effectiveness of some of the interventions you mentioned without there actually being a pandemic. Do you know how someone might...
Oh, okay, so that's the big one. I would love people's ideas on that, because how can you test whether your society is resilient against a pandemic class event without running a drill? And no politician is going to shut their city down for a pandemic drill, even after COVID, right? People want to put it behind them. I mean, we can castigate government for not investing in pandemic preparedness after a pandemic. And I like to write that off on the US government being uniquely dysfunctional, but it's not true. It's not as though other countries are investing the remotely adequate sums, even what economics would suggest is necessary, given that there's on average 4 natural pandemics per century, at least those that cause more than 1 million deaths. Governments are just not doing this because people don't want to think about it. And if there's no human adversary to focus on, at least this is my best idea, people just don't get worked up enough about it in a sustained kind of way. We're in the beyond COVID era. The world wants to put it behind them. And I'm not sure how to combat that. Yeah.
You mentioned the idea of having rapidly deployed tests, which are cheap and accessible. Could you say more about what you think the path needs to be to those tests?
Yeah, so there's a lot of promise there, and there's active debate between the proponents of different camps. There's the folks who say, we need to switch and go all in on CRISPR-based tests. And there's the folks who say, no, PCR is quite good enough, we just have to figure out how to scale it. And then there's folks who have sort of dark horse other contenders out there for diagnostics of various kinds. But the real trick is whatever the diagnostic needs to be, it has to be adaptable. So both the CRISPR and PCR-based can be adapted to any given threat. But if you're looking at like the physical characteristics of the virus, what if the adversary uses something else, right? If all our defenses are built around, oh, we can reliably detect viruses of these families, then someone who wants to kill a lot of people is just going to use something from a different family. And we should assume that the threat can come from pretty much any family. So I'm not sold on any one particular kind of diagnostic as long as it can be adapted to detect any biological threat very, very quickly.
So one issue that came up against COVID was the length of the trial the vaccines needed to go through. How can we ensure things like that don't happen again? Do you think about how to improve that kind of system?
Yeah, well, a lot of folks in the community have done tremendous work accelerating challenge trials and the like. The complication is, even if you somehow knew what the agent was going to be in advance, even if you identified a pandemic-capable virus in nature, say, and wanted to create a vaccine for it, you can make the vaccine. I mean, if it's an mRNA vaccine, you can make it in a day. But you can't run a phase 2 challenge trial to see if it works. Because to do that, you'd have to infect a bunch of people with a virus of unknown lethality that has never infected a human, and if you didn't do this, might never. So that's the real challenge. You just can't run the phase 2 until the thing's already out there. And if we're willing, we should at a minimum be willing to run combined phase 1 and phase 2 trials immediately. That is, we learn of a novel agent that is spreading. We should have vaccine factories that can immediately churn out a vaccine within a couple of days. And launch a combined phase 1 and phase 2 trial using ring vaccination around wherever the areas that the threat appears to be present are, in order to determine whether it works and give us the best chance of stamping it out. And right now, there's at least interest in doing that because people recognize that emergency use authorization is not really designed for actual emergencies. So that is a policy hurdle that we're going to have to overcome because a lot of the folks at these agencies have just not, like, their incentives have been shaped in normal times, shall we say. There's no one there who has been shaped under incentives of a true emergency under the pandemic. So we need to find those very few people who have any kind of credibility in these circles, who acted very quickly with COVID and understood that challenge trials were probably necessary and things like that, and try to usher them into the relevant policy positions and encourage politicians to recognize this as a problem and sort of specify, we need a sort of a backup team. You know, you declare an emergency and now the acting chair of the FDA with respect to vaccines is not the current FDA commissioner, it is someone who is specifically approved in advance to be the person to take over in a pandemic emergency. And we might want to do this for many different relevant agencies. That's sort of a broader policy question that I would definitely defer to other folks, but our society is not good at adapting to radically different conditions. So one plausible way of dealing with this is to say, we need some way for people to declare an emergency and then have a completely different set of people take over whose job it is to prepare for that emergency at all times in case they're called upon. How to get there? I don't know. Policy folks, please work at it.
We have a lot of questions coming in. I'm going to try and get to a few more. Sorry, we're a bit over time. Someone asks about privacy concerns. I know there might be trade-off for some of these interventions between the right to privacy and safety. How do you think about that trade-off? Can we still have the right to privacy in these worlds?
Yeah, so the sequencing-based monitoring preserves privacy as long as you are mixed together enough samples. And it's actually quite difficult to sort of fish a human genome out of that in particular. And if people want your genome, they can get it anyway. So it's mainly a matter of perception. The real one that would raise issues potentially is that early warning system. How far away is the threat from you personally? Because that requires creating a social graph. But this seems to be a problem that cryptography could address, even in a completely decentralized manner. And that is, again, I think, an area where we just need some active exploration because the folks who are cryptographers don't normally think about the pandemic risks that much. So we need the sorts who addressed sort of exposure notification and the privacy concerns there to think about how we can do this sort of social graph-based early warning method. And there's Po-Shen Lo at Carnegie Mellon has done a lot of the early work on this. So any of you who are interested in following up and trying to figure out better ways to do that, I highly recommend reaching out to him.
Okay, great. We'll just take a couple more since there's another talk in here very soon. Have there been cases of pathogens escaping from labs and causing harm?
There absolutely are instances of pathogens escaping from labs and causing harm. In fact, in the UK, a leaky pipe from the Pirbright Institute caused multiple outbreaks of animal class pandemics within weeks of each other. So yes, leaks are a thing. They will happen. For our purposes, probably the greatest concern is a leak from an actual weapons lab. Because natural pandemics are just not threatening enough on their own that an individual leak can cause anything worse than a natural spillover event. And we know that natural pandemics are very, very bad, but they are not on their own going to threaten the stability of civilization.
Yeah. Okay, one last question to wrap us up. There are a lot of scary risks you've talked about. What gives you hope in this space?
Because this is a solvable problem. This is solvable. Biothreats are solvable. In fact, we see how to do it. It doesn't even require radically new technologies that we don't have. We have very similar technologies to these in many different areas. We just have to apply it to resist this. And that's something that we can do. That's something that this community can do. We have the resources, we have the talent, we can do it. And I'm actually quite optimistic as well, because if you sort of flip the hat around and like, well, if you are on the other teams, shall we say, it's actually quite difficult to do anything because all the low-hanging fruit just makes the rest of the world pay more attention to those of us who are saying we need to do all of this stuff. So on the whole, I think we're in pretty good shape, oddly enough, against bio, but it's good shape in the sense that there is a light at the end of the tunnel. It's clearly there. We just need to get there. Whereas other causes, shall we say, are a little bit murkier. So I'm actually really optimistic about bio.
Okay, on that note, another thank you to Kevin Esvelt.